All right, so this is section 1.5, day 2. Now, just to kind of give you guys a heads up of where we're headed, again, we got 1.5, day 1 was Thursday, day 2 is today, and then we're going to do section 1.6, 2 days on 1.7, and then we're going to have our test over chapter 1 a week from today. Which is next Tuesday. Okay, next Tuesday we're going to have our chapter 1 test. We're going to be done with the material by Friday. We'll review Monday, test on Tuesday. All right, so what we're going to do today is more like weird things that can happen with equations. And then we're going to look at some word problems as well. So the first thing that we're going to talk about is what happens when all the variables cancel out. Now remember, when we solve these things, we want to move the variables all to one side. That's the key thing here. Move the variables all to one side, by doing so, we're going to get rid of the little guy, which means move the smaller variable first. Now, you can do this with me, or you can just watch. This is completely fine. But if I were to solve this equation, the first thing that I would do would be to distribute in the 2 to get a 6 plus 2x is equal to 2x plus 6. And then I'm going to get rid of the little guy. But wait a second, there is no little guy. They're both 2. So let's just pick one and move it. Let's just say, okay, I'm going to move this one from the left side to the right side. And by doing so, I would be subtracting 2x from both sides. Now watch what happens. We know it's going to cancel on the left side because that's how it's going to move it. Are we okay, gentlemen? Or can we stop the goofing off and just pay attention? Brendan, you haven't been here for a while, so I would pay attention. So what's going to happen to the right side as well? It's going to cancel there as well. That's recorded on video, folks. And now that cancels out. We got 6 is equal to 6. Now, when variables cancel out, weird things happen. And when I say weird things, I mean special cases happen. This is a special case. My variables have canceled out, and now something different has happened. We're not going to get x equals a number. We're not going to get just one solution. If you get something that is true, like I get 6 is equal to 6, that's a true statement. If you get something that's true, then what we have for our answer is this symbol. Does anybody know what that symbol means?
Does it mean that both of them are the same?
Not exactly. This means all real numbers. That's what that symbol means. We rate it as all real numbers. That means anything could be a solution. Pick 10, plug it in, it's a solution. Pick negative 10, plug it in, it's a solution. Pick 50, plug it in, it's a solution. Pick 1,000,000, plug it in, it's a solution. Any number that you want to plug in, it would make that a true statement. That's called an identity. When solving an equation, if you get an equation that is always true, if you get a true statement in the end, if you get the equation that is always true, the original equation is called an identity, and it has infinite solutions. Meaning anything that you could possibly plug in would be a solution. As long as you get a true statement in the end, where it's like 2 is equal to 2, or 6 is equal to 6. 6 is equal to 6 is not the answer. 2 is equal to 2 is not the answer. 3 is equal to 3 is not the answer. What the answer is that there's infinite solutions, that all numbers could be a solution. Okay, so what happens if we go to solve this thing, just like this one here, and I would subtract the 2x's, just like we had on the last problem, and now this would cancel and this would cancel, but look at what's left over. I've got a 3 is equal to negative 4. Last time I checked, 3 is not equal to negative 4. Let's check again. Okay, no, it's not. 3 is not equal to negative 4. I get a false statement. I get something that is not true. If you get something that is not true, that means this is your answer. So if an identity meant that anything could work, this means that nothing could work. Or as we would read it, no solutions. That's how we read that symbol. If you want to write out all real numbers and no solutions, like write out the phrase, by all means, go for it. But for me, all I need are the symbols. Question?
No, I'm good. Never mind.
Okay. Again, this is what's called a contradiction. Mathematically, it's called a contradiction, which is not just a math term, math vocab. That's you could use that term in your everyday life. A contradiction is when you say something and then you say something opposite of it. Like I say, I have 3 and then I have -4, and I say those things are equivalent. No, I'm contradicting myself. It basically means you're going to get an equation where the left side does not match the right side. And if the left side does not match the right side, there are no solutions to that equation. So let's practice it a little bit. Now on your homework tonight, the worksheet that I'm going to give you, there's a lot of problems on it. Are they all going to be either no solutions or all real numbers? No. A lot of it is just solving equations. If you happen to cancel out variables from left side to right side, then it could be a no solutions or all real numbers. So let's first start off by combining like terms. I've got the 10 and the 1 to make 11. I've got the 7x and the minus 12x to make -5x. You may see it right now. You may see, something weird is going to happen because there is no little guy. The variables match. If I were to move the variable over to the other side, no matter which one I'm focusing on, they're going to cancel out both sides. That means I get an 11 is equal to 11. That is not my answer. My answer is not 11 is equal to 11. If you put 11 is equal to 11, I'm going to mark it wrong on the answer blank. What's my answer? Yep. All real numbers, right? And again, that's a bold R. That's the symbol that I'm trying to make here. A bold R, which means I'm going to double line my left side, start the R from the left line, and attach it to the right line. That's a bold R. If you want to write out the phrase, all real numbers, that's completely fine too. I've had students in the past do ARN for all real numbers. That's completely fine too. Okay, in converse to that, I've got 12x minus 3 plus x is equal to 5x minus 4 plus 8x. All right, so let's combine like terms on the left side. I've got 12x and 1x to make 13x. I've got 5x and 8x to make 13x. So I can already sense that something weird is going to happen because my variables are matching. And when your variables are matching, that tends to throw things off a little bit. So I'm going to subtract the 13x from both sides. When we do that, I get a -3 is equal to -4 because they end up canceling both the left and the right side. So what's my answer? What's my answer? Yep. No solution. Good. No solution. There is no solution to that equation. No numbers would work. Nothing would work. You can try for the rest of your life plugging in numbers for x and nothing would work. Take a look at our last one here. 4y plus 7 minus y is equal to 10 plus 3y. All right, I've got 4y minus y to get 3y. Nothing to combine on the right side. I see again, my variables are matching. Now, if my variables weren't matching, I just solved this like any other equation. Like if this was a 2y plus 7 is equal to 10 plus 3y. Okay, I've got a little guy. Move it over and solve like I always would. But because I see that my variables are matching and I move the 3y over to the other side, I notice here that those are going to cancel, and I'm going to get 7 is equal to 10. So what do I put on my answer blank?
No solution symbol?
No solutions. Good, no solutions. Again, if you put 7 is equal to 10, that's not the answer. The answer is no solution. All right, flip it over onto the back. So now what we're going to look at for the rest of the day today are word problems. Doing some word problems. All right. 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7. How old is Greg? All right. So what is my unknown? What am I looking for? What's going to be my variable? His age. Greg's age. So let's make X. That's be boring. Let's say X is Greg's age. All right. So now we say 4 times Greg's age. 4x. Decreased by 3 is equal to 3 times Greg's age increased by 7. Okay, so all I did there was take each piece and take it from words and put it into math. That's all I did there. And now we saw, what's my little guy? The 3x. So let's move the 3x over to the left side by way of subtraction. So I get x minus 3 is equal to 7. Then I add the 3 to both sides. So x is equal to 10. So what's my answer? What's my response back to this question, Danielle?
Greg's age is 10.
Good. Greg is 10. Greg's age is 10. Good. Okay, let's take a look at the next one. Now, this is a little bit more real life. I feel like I do these equations all the time. I'm trying to compare 2 businesses against the next. I've got a quote from one and a quote from the next. From landscapers. I do this all the time with I try to run the numbers on like my phone bill, my internet bill. So this is a real life example here. A painting company charges $250 base plus $16 per hour. Another painting company charges $210 base, but they charge $18 per hour. So notice the difference. One charges more right off the bat, but less per hour than the other. So I want to know, okay, when's the cutoff? When are they going to equal out where one is going to equal the next? Where one is going to be like, okay, now they're the same amount, they can start overtaking the other. How do I create my equation here? How do I create my equation? Or what is my equation that I have? I have $250 base plus $60 per hour, and then $210 base plus $18 per hour. It's okay.
You do 250 plus 16x
Good.
equals to 210 plus 18x.
Good. Where x is what?
The per hour.
Good. Good. I've got 250 base, which means that that's the initial amount. The base amount, the base price, that's the initial amount. You're not going to keep paying that amount. That's just a one-time fee. Plus $16 per hour. That's where my times x comes in. All right, now what is my little guy here? Which one is my little guy? Gio?
16x.
The 16x. Let's subtract 16x from both sides. So we take 250 is equal to 210 plus 2x. We subtract the 210 from both sides. And we get 40 is equal to 2x. That's it? Good. We divide by 2. And x equals 20. All right, so let's put it back into context. I know my solution was 20, but what's the answer to my problem here? What's the answer to my problem?
They both provide. The 2 companies would be the same amount of money at 20 hours.
Good. Yeah, this one's kind of a hard one to word. Right? This one's kind of a hard one to put into words. For the 2 companies to cost me the same, it would take 20 hours. Okay. The cost would be the same at 20 hours. O-U-R-S. So that means that if it's less than 20 or more than 20, I have to go in and examine, okay, which company is going to be the best route to take? Which one's going to be cheaper? Okay? And we'll talk, when we get into the inequalities chapter, the less than, greater than, less than or equal to, greater than or equal to, then we'll really talk about, okay, when is the benefit? How much is it going to be greater than? Let's take a look at our last one here. Now, just because you see a diagram does not make this problem harder. The OST loves to give you information that's within a table and make you use that information to create an equation. For example, the table shows pricing information for 2 pizzas. How many toppings would make the cost the same for both pizzas? Whenever you see like things wanting to be the same, that means I'm going to create an equation. All right, so maybe I've got 2 different pizza places, pizza A, pizza B. Maybe one's Pizza Hut, one's Papa John's or something. I don't know. But let's take a look at what's happening. For a plain pizza, at the first place, it's only $10, but for the second place, it's $12.50. However, if I start adding toppings, so if you're going to get a cheese pizza, go with place with A. But if you start adding toppings, then the first place is going to charge more per topping than the second place. So there has to be at some point an amount of toppings where they're going to be the same. And then once I go beyond that, okay, it's going to be more beneficial to go with the other place, pizza B. So let's see how many toppings that's going to work with. So let's take our base prices plus the amount per topping. Let's make X the number of toppings. So this is 10 plus 1.5x is equal to 12.5 plus 1x. See what I did there? 10 plus 1.5x is equal to 12.5 plus 1x. Okay, now we can get rid of the little guy. We subtract the 1x from both sides. So we get 10 is equal to, got my variable. 10 plus 0.5x is equal to 12.5. We subtract the 10 from both sides to get us a 0.5x is equal to 2.5. We divide by 0.5, and that's going to get us x is equal to 5. So answer the question. I know I get x is equal to 5, but what's the answer to my question?
The pizzas cost the same every 5 toppings.
Good, for 5, at 5 toppings. The pizzas cost the same at 5 toppings. Questions about that? Okay. So what did we learn today? We learned about, okay, if the variables cancel out, weird things may happen, and then we talked about some word problems. Tomorrow we get to talk about some absolute value equations. Absolute value equations. All right.